Chapter 11, section 4 and 5 is on the factor theorem. And so basically we have to talk about some vocabulary. And what we're going to be doing today is using the factoring that we've been doing to find the zeros of a polynomial. And the zeros basically are just the x-intercepts. The maximum number of zeros we are going to have is based on the degree, which again is the largest exponent. So if it's a third degree, the most zeros you're going to get is 3. Fourth degree, 4, etc., etc. The roots, sometimes they'll use roots interchangeably, which just means the zeros, again, which is the x-intercepts. So zeros, roots, x-intercepts all mean that you're trying to find where it crosses the x-axis. And the factor theorem that we're going to be working with for the next couple days here says if x minus r is a factor, then r has to be a 0. So if your factor, which we've been factoring for the last couple days here, said x minus 5, that would mean that 5 is a 0, which means it would cross the x-axis at 5. So using the factoring, which is why we spent so much time on it, we can determine where it crosses the x-axis because that means it's a 0, and then we can begin to graph these polynomials. So we're going to go ahead and kind of just take a look at what this would look like kind of in a chart form. So our first example says 3x squared plus 14x minus 5. And you're going to factor it, okay? So everything we did last week comes into play. So again, to get 3x squared, we would use 3x and x. Then you look at your last number, which is a 5, keeping in mind that we have to get to a 14x. So if I use 1 and 5, my outsides now give me 15x and my insides give me 1x. So to get 14, I need a plus 15 minus 1. Okay, so that would be my factors. Now here's the new stuff. So that was old. The zeros mean find the 0. Okay, so what you're going to do is say, okay, if my factor is 3x minus 1, I want to know when that would equal 0. So I would solve. So I'd get 3x to equal 1. So x would equal 1/3. So if you plug in 1/3 for x into this first factor right here, you should get 0, which means the value of x would be 1/3. And then our second factor is x plus 5 to equal 0, so x would equal -5. So your two zeros in this first equation are 1/3 and -5. Okay, now keep in mind, we said the maximum number we could have was the degree. We found two zeros, and it was a quadratic, okay, which should make sense. So you should find the number of zeros that your degree is. Okay, so let's try example B, 10c squared minus 17c plus 3. So again, you're going to go ahead and factor that. To get to 10c squared, we'll use 5c and 2c. And then looking at the 3, my options are just 1 and 3, but I need to get to a -17. So I'm going to go ahead and put my 3 over here and my 1 in my first factor. So now if I need -17, the outsides give me a -15. The insides can give me a -2, so I get -17 total. Okay, so that's the old stuff. The new stuff says, okay, what does that mean my 0 is? So you just take each factor and you set equal to 0. So 5c minus 1 equals 0. So 5c equals 1. So c would equal 1/5. The second factor would be 2c minus 3 equals 0. So 2c equals 3. So c equals 3/2. So your your two zeros here are 1/5 and 3/2. Okay. Part C, okay, difference of squares. That's a binomial. So again, we're factoring. So square root each one. So that would give me 9x and 11, 9x and 11, 1 plus and 1 minus. Okay, so again, just what we did last week. The new stuff is finding the 0. Okay, so my 0 here, so I'm just going to set 9x minus 11 to 0, and 9x plus 11 equal to 0. Okay, at this point, I'm not sure if you actually need to write out all the steps I did in the first two. The first 0 is going to be 11/9, and then the second one's going to be -11/9. Okay, so there's your two zeros. I don't need to see that step, okay, but I'm trying to show you where it comes from. Hopefully, eventually you can start to do that without that step. Again, I got two zeros and my degree was at 2, so I match. Letter D, factoring. Okay, let's see if you notice what this is different about D. Okay, it's got an x to the third. So this time I should find 3 zeros, but hopefully you remember that you cannot factor, okay, with a x to the third. So I'm going to factor out a 2x first, leaving me with a 6x squared minus 5x minus 21. And then I'll break that down again, leaving my 2x on the outside. So then I'll maybe use 3x and 2x here. And then 21 will be 7 and 3. And I'm trying to get to 5. So let's try 7 and 3. The outsides give me 9 and the insides give me negative 14. So that will work if my 14 is negative and my 9 is positive. Okay, so again, you're going to set your factors equal to 0. So for 3x minus 7 equals 0, you'll get x equals 7/3. For the second one, 2x plus 3 equals 0, you're going to get x equals negative 3/2. So you have 2 zeros. But you should be kind of thinking, but wait, this was originally next to the third, which means we need 3. Okay, so here, this 2x right here stands for a factor. So you also have to say, okay, what if 2x equals 0? Then x equals 0. Okay, so our 3 zeros are 0, 7/3, and negative 3/2. Okay, so if the degree is 3, you should have 3. Don't forget about that 2x out front. Okay, that's going to give you 0. Sorry, my chart's getting a little messy. Okay, pause if you didn't get that. I'm going to erase this so I can move on to the next one and I'm not running out of space here. I write kind of big. All right, so E. Again, we've got a p to the third, so I need to get rid of it. So I'm going to factor out a 5p first, leaving me with a p squared plus 2p minus 8. I'll factor that down again, so I'll leave my 5p out front. That will give me a p, and 8 will be 4 and 2. And I need a plus 2, so I'm going to say p plus 4, and then p minus 2. So the outsides give me negative 2, and a positive 4 gives me the 2p I'm looking for. Okay, so now I'll get my 0, so set each one equal to 0. So the first factor is the 5p, don't forget about that. So that's going to give me p equals 0. My second one, p plus 4 equals 0, is going to give me negative 4. And the last one, p minus 2 equals 0, is going to give me p to be 2. So I've got negative 4, 0, and 2. So I got 3 zeros. I started with a degree of 3, so I should be all set. And my last one, hopefully you guys are kind of getting the hang of this. This one's got a degree of 4, so I should find 4 zeros here. Again, you can't factor if that's on x squared, so I'm going to factor out a 4. Oopsies, how about a 4x squared is probably even a better idea here. So I'll factor out a 4x squared, leave me with an x squared minus 10x plus 25. Okay, I'll break that down again. So I've got x and x. 25 is going to be 5 and 5. I need to get to a negative 10, so I'll subtract both of those, and I'll keep my 4x squared out front. So now to get my zeros, okay, I've got x minus 5 equals 0. So that's going to give me x equal 5. I'm going to get the same one for the next factor, so I'll have another x equals 5. And then my 4x squared equals 0 is going to give me a 0. Okay, so that technically gives me 3 and I'm supposed to have 4. Okay, but this x squared really means that we're going to count that 0 twice. And we're going to talk a little bit more about that tomorrow. It's called multiplicity. So that's a little bit more of tomorrow's topic, but just realize that the x squared is going to give us 2. So we've got 2 zeros, 2 5s for a total of 4. So that's the basics. Let's see if we can now use that idea to work ourselves backwards. So if I'm saying now that my 0 is a 4, what does that make my factor? Okay, well, we said before, if we had x minus a factor, and that was our 0, okay, so now I'm saying x minus something has to equal 4. Okay, well, x minus 4 is going to be my factor. Because if you say, okay, x minus 4 equals 0, it's going to give me x to be 4 for my 0. So you're just kind of working yourself backwards here. Keeping that idea in mind, if I had a negative 3, that factor should be x plus 3. So it's kind of an opposite. To get 0 out, that's just going to be x. Because then if I set my factor x to equal 0, I'd obviously get 0. Okay, now the next one, hopefully if you're following the pattern, that would be x minus 2/3 equals 0. However, when we write our factors, okay, we never have a fraction in here. So what you're going to want to do is you're going to want to kind of rearrange this. So that becomes 3x minus 2 to equal 0. Okay, so how did I do that? I took my denominator, okay, and I moved it out front. Now you're like, how does that work? Well, if we were to solve this factor like we were doing on the front, we would add 2 and then divide by 3, so I would get 2/3. Okay, so the shortcut is take the denominator and move it up front. So this is going to be the factor 3x minus 2. Negative 2.5 is the fraction negative 5/2. So if I move the denominator out front, that becomes 2x. It's kind of opposite day, so then plus 5. Again, if you're not sure, just check your work. So if I say 2x plus 5 equals 0, I'd subtract 5 and divide by 2, so I get negative 5 over 2. So we're good to go. Okay, and the same idea, only now writing an equation. Okay, so if I give you the zeros, can you write the equation? Okay, can you write the polynomial? Okay, so I'm going to say p of x are polynomial, and now I'm just going to make a factor for each zero. So the factor for negative 1 should be x plus 1. The factor for 0 is just x. Okay, anytime you have a 0, it's customary to put that x out front because it doesn't have anything to go with it. So you should put that there. And then the 5 will be the factor x minus 5. Okay, now the tricky part is this says the fourth degree. Right now, I have 1, 2, 3 zeros accounted for. So like we were talking about before, the x squared counted as 2. So if I make that an x squared, now I have 2 here, 1 here, 1 here, all together for a fourth degree. And nothing changes it because x squared to be 0 is still 0. So I haven't changed the 0, I just added it to give me another degree. So that is what you are looking for here. Okay, so in H, we'll use that same idea. So general formula of a polynomial, p of x, 0 is at 0, so there's going to be my x. 2/3, again, you move that denominator, so that's going to be 3x minus 2. And negative 5/4. Move your denominator. So that'd be 4x plus 5. So move the denominator, change the sign. Now this time it says a fifth degree. So right now I've got 1, 2, 3, and I need 5. So if I change this to a 3, now I've got 3, 4, 5. So now I'm good to go. Okay, so you can play with the exponent on this x. You can play with the exponent on any of them as long as when you add them, they all get to 5. Okay, so another way to do that, I could say x squared. I could say 3x minus 2 squared, and then 4x plus 5 to the first. So then I have 1, 2, 3, 4, 5. Okay, so any way you want to arrange it, you can always change the exponents, okay, just not what's under inside. Okay, so go ahead and jot down some questions you still have and bring those to class tomorrow.